In a smoothly functioning pipeline operation, the liquids we pump will rarely be seen until they reach their ultimate consumer. But we come in contact with crudes, products, and chemical feedstocks, sometimes on purpose for samples or tank inspections, and sometimes by accident through an equipment breakdown, leak, or spill. This program, Handling and Transporting Hazardous Liquids, is one of a series of training programs developed by Amoco Pipeline to acquaint you with pipeline operations. During the first part of this presentation, we will look at the definition of a hazardous liquid, explain how to read a material safety data sheet, and show how the liquids we pump fit into the broad categories of hazardous materials. The other parts of this program will cover the hazards associated with crude oils, refined products, NGLs, and chemical feedstocks. Let's begin with the definition of a hazard according to the Department of Transportation. First, is the substance flammable? By definition, a flammable liquid has a flash point below 140 degrees Fahrenheit. A combustible liquid has a flash point above 140 degrees Fahrenheit. Second, is it reactive? A reactive liquid makes violent changes in substance, which means it is unstable either by itself or when it comes in contact with substances such as oxygen, water, sunlight, or other catalysts. Is it corrosive? Sulfuric acid is a good example of a highly corrosive material. Is it toxic? How is the substance toxic? Do you have to eat it, breathe it, or just get some on your skin or in your eyes? Obviously, most substances won't fall into a single hazard category. It is more common for a hazardous liquid to show several hazardous characteristics, such as flammability and reactivity, or flammability and toxicity. Although not listed by the Department of Transportation as a characteristic of hazardous materials, a hazard associated with liquefied gases under pressure is extreme cold. If a leak should develop in a liquefied gas line, the rapid expansion of the line fill from a compressed, liquefied state to a vaporous, gaseous state will cause the gas to cool very rapidly, often freezing the leak site and some of the surrounding area. Remember, if your skin comes in contact with the product at the leak, your skin can freeze too. Simple pressure on the line is another major danger to personnel. For example, while 10 pounds per square inch doesn't seem like much compared to normal line pressures, consider what happens when 10 psi is standing behind a 10-inch diameter blind flange. There is 78.5 square inches of area on the back of that blind flange. Each square inch has 10 pounds of pressure behind it. That's 785 pounds of force held captive by the flange bolts. If the flange is removed without bleeding off that last residual pressure, you might wind up with injuries from the sudden release of that force. Always remember that pressure is a hazard on any pipeline system, whether the line fill is nitrogen, water, or hydrocarbons. The Standard Oil Company Product Safety section has published material safety data sheets on many of the products we pump in our pipelines. Let's go through a typical material safety data sheet, or MSDS, step by step, so you will be able to read and understand one. This MSDS is for JP4 jet fuel. The first section identifies the material by its trade. The product identification is aviation turbine fuel. Also included is a warning statement and the substance's Department of Transportation Hazardous Materials Classification, flammable liquid. The EPA number is a code assigned by the Environmental Protection Agency for classification. The chemical formula may also be provided in some cases. Another section identifies the important components of the material, in this case, petroleum naphtha. While no permissible exposure concentration has been determined for JP4, an MSDS for another material may show a threshold limit value, or TLV. The TLV is any limit, established or estimated, at which the concentration of the material may present a hazard. A very important section of the MSDS covers health effects of exposure to the material. For some substances, you may see the abbreviation LD50 or LC50. This stands for the median lethal dose, LD, or lethal concentration, LC. The definition of a median lethal dose or concentration is that dose or concentration of the material which will produce death in 50% of test animals. This, of course, is measured in a research lab. Some material data sheets may include information on a sensitizer in this section. A sensitizer is any substance which will cause a major reaction on another exposure to the same substance. This might best be compared to the experience of someone allergic to bee stings who has been stung several times. Each time that person is stung again, the reaction gets more and more severe. Another important section is titled Emergency and First Aid Procedures. This section deals with the necessary first aid to take in case of exposure to the substance. The Personal Protection section shows what precautions you should take if you work in contact with the substance. It may recommend, for example, types of eye protection or respirators. The next section, titled Fire Protection Information, covers several standard measurements that have been determined by laboratory analysis. The first one is flash point. Next to that is auto-ignition temperature. This is the minimum temperature required for a substance to catch fire in the absence of a spark or flame. The flammable limit defines the range of gas or vapor concentration in percent by volume in air, which will burn or explode if an ignition source is present. For JP4 jet fuel, the upper limit for explosivity is 8%, and the lower is 1.3%. Above that upper limit, ignition will not take place because there is not enough oxygen in the air to support the fire. Below that limit, there is not enough fuel in the air. The next category listed is extinguishing media. That is, what firefighting agent should be used. Dry chemical or BC extinguishers, carbon dioxide, water fog, and foam will all work to extinguish a JP4 fire. The next item in this category lists any unusual fire and explosion hazards. Physical properties are determined by laboratory testing. Vapor density is the relative weight of a vapor or gas with no air present, compared to an equal volume of air at normal temperatures. If air equals 1, a vapor density above 1 means that the vapor will sink into low spots. A vapor density smaller than 1 means that the vapors will rise into the air and dissipate. The MSDS also lists pH, which is a measure of the degree of acidity or alkalinity of the material. In the case of extreme corrosives, such as sulfuric acid or sodium hydroxide, pH is an important item. The specific gravity listed for JP4 jet fuel in the next line is 0.74 to 0.8. Specific gravity is the ratio of the weight of a volume of the material to the weight of an equal volume of water. A specific gravity less than 1 means that the substance will float on water. A specific gravity greater than 1 means it will sink. JP4 will float on water. JP4 is not, to any degree, soluble in water. That means that it does not mix with water and will cause a slick. Viscosity, appearance, and odor to aid in identification are listed next. Hazardous polymerization is the next line. Hazardous polymerization is very closely related to reactivity. It means that a change in the molecular structure of the substance takes place at a rate which releases large amounts of energy. Note that hazardous polymerization does not occur with JP4. The next line shows products formed when subjected to high temperature or combustion. The materials to avoid line shows strong oxidizers. An oxidizer is a substance which can cause the material to react violently by providing oxygen, releasing large amounts of energy. Pure oxygen is an excellent oxidizer, as you might imagine. The next section on this page shows storage and environmental protection. JP4 jet fuel should be stored in a flammable liquids storage area. In case of breakage or leakage, instructions are to shut off all sources of ignition and use a water spray to disperse vapors. Next is marketing and use regulations. JP4 is not under specific regulations of either the Food and Drug Administration or the U.S. Department of Agriculture, and no other agency specifically regulates the use of this material. The final section on this page is comments. In this case, the comments include a copy of what should be on the label of a container. Now let's look at the broad hazardous categories that the hydrocarbons we transport fall into. The first category, according to the Department of Transportation hazardous listings, is flammability. Amoco Pipeline considers all crude oils, products, NGLs, and feedstocks to be a fire hazard. All the commodities we pump are DOT flammable liquids, flammable gases, or combustible liquids. The second category of hazard is corrosivity. None of our products are corrosive by definition. However, crude oils with high sulfur content can be considered mildly corrosive. H2S may change, in the proper circumstances, to sulfuric acid, and the hydrogen in H2S can cause hydrogen embrittlement of steel piping, valves, and tanks. The third category is toxicity. To some degree, all crude oils, petroleum products, NGLs, and chemical feedstocks are toxic. Some have a very low toxicity, for example, heat transfer oil. Some have a very high toxicity, for example, benzene. Any spilled crude, product, or feedstock should be considered potentially toxic to the environment, even if it is not toxic to people. The final DOT category of hazards is reactivity. If you'll remember, the definition of reactivity is a violent change in substance due to some external cause. Among all of the products we pump, only one might be considered such. Ethylene, which is pumped from the Texas City Amoco oil refinery in the Lamarck operating area, is subject to decomposition under special conditions. We'll cover the specific case of ethylene later. This concludes Part 1. We will now take a brief pause. Next, we will look at the hazards associated with crude oils and other commodities that we pump. We move many different kinds of crude oils in Amoco pipelines. These crude oils include both sweet and sour crudes from the Southwest, West, and Midwest. The sulfur content of these crude oils ranges from a low of 0.1% for the sweetest crude to a high of nearly 4% for high-sulfur Montana and Wyoming sour crudes. Crude oil with a sulfur content of 0.5% or higher is considered sour crude oil. Crude oils are sometimes mixed with condensate from gas wells before they are shipped, so the makeup of crude oil within our pipelines can include both very light and very heavy hydrocarbons. For this reason, it is difficult to categorize any specific crude as more or less hazardous than any other. However, there are certain characteristics and hazards that are of importance to us. One of the most obvious is sulfur content. A high-sulfur crude has a greater amount of hydrogen sulfide, or H2S, and is, therefore, a hazard both to health and the pipeline. Crude oils are a major fire and explosion hazard. Crude oil is toxic to animal and vegetable life and may irritate or inflame your skin. Crude oil vapors, whether sweet or sour, may cause asphyxiation or anesthesia when breathed in sufficient concentrations. In addition, depending on the composition of the crude oil, the vapors may very easily form a cloud that can be ignited. Crude oil vapors have also been linked to cancer in laboratory animals. How do you deal with these hazards? First of all, observe no smoking precautions in the area of pumping equipment, manifolds, tankage, and any leak or spill site. Secondly, if you do get crude oil on your skin, immediately wash it off and either dispose of or clean contaminated clothing. Third, seek medical attention if you should, by accident, get crude oil in your eyes or if you swallow it. Finally, make sure that there is adequate ventilation in the vicinity of any crude oil spill, leak, or accumulation within a confined area. If the crude is a high-sulfur crude, make sure H2S monitors are being used and learn how to use self-contained breathing apparatus. Wear protective goggles and gloves if you'll be in contact with crude oil. In Amoco Pipeline's product operations, we move a variety of finished refined products. These include gasolines, diesel fuel and furnace oil, kerosene, mineral spirits, and jet fuels. All of these products are classified by the Department of Transportation as hazardous liquids. The gasolines, jet fuel JP4, and mineral spirits are classified as flammable liquids. The diesel fuels, furnace oil, jet fuel type A, and kerosene are classified by the Department of Transportation as combustible liquids. Let's begin our discussion of hazards with the gasolines. In general, Amoco Pipeline pumps two kinds of gasolines for Amoco Oil and for other shippers. These are leaded gasolines and unleaded gasolines. Gasolines are very flammable. The laboratory-tested flash point is 45 degrees Fahrenheit below zero. The auto-ignition point, that is, the point at which gasoline will catch fire without a source of ignition being present, is 495 degrees Fahrenheit. Gasoline produces vapors easily, and the vapors of gasoline are heavier than the air, which means that gasoline vapors will collect in low spots. Gasoline vapors are also highly flammable. The limits of flammability are between 1 and 8% gasoline vapors to air. Within this range, gasoline can flash on exposure to a spark and may flash back to the source of the vapors. Exposure to gasolines has certain health effects. When splashed in your eyes, gasoline may cause minor eye irritation. Repeated or prolonged skin contact with gasoline will remove the oils and fats from your skin, causing dry skin and dermatitis. Gasoline vapors are intoxicating when breathed in high enough concentrations. Finally, ingesting gasoline can be fatal. Drinking gasoline is not fatal because of the toxicity of gasoline itself. When tested on laboratory rats, the median lethal dose, LD50, is greater than 5 grams per kilogram of body weight. This means that a 150-pound person would have to drink and keep down over a pint of liquid gasoline to be seriously poisoned. However, the danger is that since your stomach will not accept gasoline liquid, your natural reaction will be to vomit. If any amount of the liquid gasoline is then breathed into your lungs, exposure of liquid gasoline to the tissues in your lungs can cause chemical pneumonia, which may be fatal. The specific gravity of gasoline is 0.75. The specific gravity of water is 1.0. So gasoline will float on top of water. Gasoline is not soluble in water, so it will form a slick. A much-discussed hazard of leaded gasolines is due to the organic lead compounds, such as tetraethyl lead or tetramethyl lead. These compounds are used as anti-knock additives for motor fuel. While organic lead compounds are highly toxic in quantity, the total lead specification from the Whiting Refinery's gasoline blending operation calls for less than 4/100ths of 1% of lead per gallon of gasoline. Exposure to organic lead in leaded gasoline fuel is very minor at this low concentration. Lead compounds can, however, be found in much higher concentrations in certain situations. One is the sludge left behind in a leaded gasoline tank, which has been drained for cleaning. Where contact with concentrated organic lead compounds might be expected, full protective covering, including rubber gloves, boots, clothing, and self-contained breathing apparatus should be worn. Another hazard is suspected in gasoline. In tests with laboratory rats, Standard Oil Company found that unleaded gasoline produced kidney damage in male rats when the rats were exposed to high concentrations of gasoline vapors. The meaning of these findings in terms of human health is uncertain. While you may be exposed to gasoline vapors during gauging, tank cleaning, in pump houses where leaks may develop, or in other maintenance operations, your exposure to gasoline vapors is considerably less than the exposures used in the animal toxicity studies. How can you protect yourself against these hazards? First of all, personal hygiene is a must. If your hands get covered with gasoline, wash them as soon as possible with soap and water. Should you splash gasoline in your eyes, rinse your eyes with water, and if irritation persists, seek medical attention. Gasoline vapors in sufficient quantity to make you dizzy would also be highly flammable. Wear protective equipment, including goggles and rubber gloves, where contact with gasoline is possible, and test for flammable vapors. The next group of products we will look at are Amoco jet fuels. We pump two kinds of jet fuel, Type A, which is a petroleum distillate, related to diesel fuel and kerosene, and JP4, which is a petroleum naphtha mixture like gasoline. JP4 is considered a flammable liquid by the Department of Transportation. Type A is a combustible liquid. The health effects of exposure to either JP4 or jet fuel Type A are similar to those of other products. Eye and skin irritation may occur. Inhalation of the vapors from either of these fuels may irritate your lungs and may cause intoxicating or anesthetic reactions. Either jet fuel may be harmful or fatal if swallowed because of the possibility of exposing yourself to chemical pneumonia. Both of these products will float on water should they be spilled, and they will cause a slick since they are not soluble in water. How do you protect yourself from the hazards of jet fuel? If you splash jet fuel in your eyes, wash your eyes with water. If irritation persists, seek medical attention. Wash skin exposed to liquid jet fuel thoroughly with soap and water. Clothing splashed with these fuels should be washed and cleaned before it's worn a second time. If you inhale fumes from jet fuel, get fresh air. Avoid fire, sparks, and sources of ignition wherever vapors may be present or suspected. Test for combustible vapors and wear rubber gloves, a respirator, and goggles as necessary. Diesel fuels, furnace oil, and kerosene are petroleum distillates and are DOT combustible liquids with flash points around 140 degrees Fahrenheit. Irritation could be expected if these fuels are splashed in your eyes. Your skin may be irritated on repeated or prolonged contact with the liquid. Inhaling vapors may cause dizziness, headache, nausea, or other irritation. As with gasoline and jet fuels, swallowing distillate fuels could be harmful or fatal. These distillates will float on water, but as with most petroleum products, they are not soluble in water, so they will cause a slick. How can you protect yourself from the hazards of distillate fuels? Avoid splashing these products in your eyes or on your skin. If you do, wash with water and seek medical attention if irritation persists. Protect your eyes and skin by wearing goggles and gloves. If the ventilation is inadequate where vapors are present, use an organic vapor and mist respirator, which is approved by NIOSH. Remember, keep any source of ignition, spark, or flame away from these liquids and their vapors. On occasion, we ship mineral spirits in our pipelines. Mineral spirits is a petroleum distillate, and it may contain a small amount of benzene. The threshold limit value for mineral spirits is 100 parts per million. Health effects of exposure may include eye irritation, skin irritation, and dermatitis on repeated or prolonged contact. Breathing mineral spirits vapors in high concentrations can cause dizziness, headache, nausea, and vomiting. As with other petroleum products, Mineral spirits is harmful or fatal if swallowed. Wear eye protection, protective clothing, and gloves to avoid repeated or prolonged skin contact. If ventilation is inadequate, use an organic vapor mist respirator approved by NIOSH. The flash point for mineral spirits is 100 degrees Fahrenheit, so the liquid is considered highly flammable. Mineral spirits will float on water and will cause a slick. This covers a number of our regular products. In the next part of this program, we'll look at chemical feedstocks and natural gas liquids. Certain parts of APL's system are dedicated to the transportation of hydrocarbons, which are neither crude oils nor finished refined retail-type products. This category includes natural gas liquids, or NGLs, which we move from Wattenberg, Colorado to Bushton, Kansas. Xylene, which moves from the Whiting Amoco refinery to the Decatur, Alabama Amoco Chemicals plant, and the petrochemicals moving to or from the Texas City Amoco oil refinery and Chocolate Bayou Amoco Chemicals plant. Let's begin this discussion with a look at NGLs. When natural gas comes off a well, it's treated in a gas plant to remove the most immediately saleable product, principally methane, for sale to gas pipelines. Contaminants such as H2S, water, nitrogen, and carbon dioxide are removed if necessary, and the resulting natural gas liquids remain. Natural gas liquids are composed of highly useful hydrocarbons, including ethane, propane, isobutane, and butane, pentane, hexane, heptane, and sometimes octane and other components. All are made up of carbon and hydrogen atoms, combined in increasingly longer chains of increasing weights. The heavier components of NGLs, pentanes, hexanes, heptanes, and octanes, are classed as liquids, while ethane, propane, isobutane, and butane are gases. This mixture of hydrocarbons is pumped in our pipeline at pressures over 350 psig, at which all the components of the mix perform as liquids. Let's take a look at the physical properties of these components of NGLs. The gaseous and liquid hydrocarbons in NGLs are all classified by the Department of Transportation as highly flammable. Octane, one of the heaviest liquid components of NGL, has the highest flash point in the group, 56 degrees Fahrenheit, and the lowest auto-ignition temperature, 428 degrees Fahrenheit. Ethane, the lightest gas in NGLs, has the lowest flash point, minus 297 degrees Fahrenheit, and an auto-ignition temperature of 959 degrees Fahrenheit. Obviously, NGLs present a major fire and explosion hazard. The vapors from NGL components will seek depressions and low-lying areas, since they are all heavier than air. These NGL vapors may also form a visible cloud when in high concentration, although in general the gaseous hydrocarbons are colorless and the liquids are water clear. Flammability ranges for NGL vapors go from 3% to 12.5% for ethane, to a range of 1% to 3.2% for octane. However, since ethane may be undetectable by smell within its explosive range, a combustible gas test is the safest course. Fighting NGL fires includes shutting off the source of fuel, removing sources of ignition, dispersing unignited vapor clouds with water spray, and using foam, dry chemical, or carbon dioxide to extinguish the fire, since water may be ineffective. It may be necessary to let the fire burn itself out once the fuel supply is shut off. While fire from sparks or other ignition sources is a major hazard, a sudden compression of an NGL line or other hydrocarbon pipeline also can have hazardous effects. The first effect is like the combustion sequence in a diesel engine. A very quick pressure rise against a closed valve or other internal block has an effect like a piston in a diesel engine cylinder, possibly causing an explosion by pressure shock. In addition, compressing a gas very quickly will build up heat within the system. Simple inert nitrogen, quickly compressed from 0 psig to 1300 psig, could reach 1500 degrees Fahrenheit, well above the auto-ignition temperatures of the NGL mix. To avoid the hazards of either heating effect or pressure shock, static lines at low pressures should be gradually raised to operating pressures, rather than being boosted to full operating pressures in under a minute. Toxic effects of hydrocarbons in natural gas liquids increase with the weight of the component. Ethane, like methane, which is the major component of home heating natural gas, is classed as a simple asphyxiant. This means that if the concentration of gas is high enough to displace oxygen in the air, oxygen starvation or asphyxia may result. Propane gas in a high concentration may cause dizziness in a few minutes, but there are no permanent effects and no irritation. Isobutane and butane, both gases at standard temperatures and pressures, can cause drowsiness or dizziness at a 1% concentration. Pentane is the lightest component of NGLs that is classified a liquid. Breathing pentane vapors can cause intoxication and dizziness. The threshold limit value for pentane is 600 ppm. Hexane, also a liquid, produces more toxic vapors. Hexane vapors can produce dizziness and giddiness when breathed, and repeated exposures over the long term may produce other nervous system effects. The TLV for hexane is 50 ppm. Heptane vapors may cause vertigo, the inability to walk a straight line, and incoordination. The TLV for heptane is 400 ppm. Octane vapors may act as a simple asphyxiant, that is, they may displace the oxygen in the air at lower concentrations, and may have narcotic effects in high concentrations. Octane's TLV is 300 ppm. The easiest way to avoid the effects of NGL vapors is to test for their presence at leak sites and within enclosed areas where the vapors may accumulate. Remember that the toxic effects of these hydrocarbon vapors and gases are slight compared to their potential for fire and explosion. Xylene is pumped from Amoco Oil's Whiting Refinery to Amoco Chemicals' Decatur, Alabama plant for use as a chemical feedstock. Xylene is an aromatic hydrocarbon with a characteristic aromatic odor, and it's a clear, colorless light liquid. Xylene's flash point is about 90 degrees Fahrenheit, and its auto-ignition temperature is around 900 degrees Fahrenheit. Xylene liquid will float on water, and xylene vapors are heavier than air, so they may accumulate in low areas. Xylene is toxic to humans and animal life. The threshold limit value is 100 ppm. Xylene can be absorbed through the skin. Contact with xylene will cause skin irritation and can cause dermatitis on repeated contact. Xylene will also irritate your eyes and is harmful if the vapors are inhaled or the liquid is swallowed. If you may come in contact with xylene, wear chemical goggles, protective clothing, and gloves. An organic vapor respirator should be worn if vapors are present. First aid procedures include washing affected areas and seeking medical attention. Amoco pipeline operations in the Lamarck area include the chemical feedstock lines from Texas City Refinery and Chocolate Bayou Chemical Plant. The hydrocarbons in those lines include ethane, propane, propylene, ethylene, butane, hydrogen, and butene, which are all gases at 60 degrees Fahrenheit and atmospheric pressure, and benzene, debutanized natural gas, or DNG, and pyrolysis gasoline, which are liquids. All are highly flammable. All but hydrogen will accumulate in low spots, and some of these substances have toxic effects. We've already mentioned ethane, propane, and butane in the section on NGLs. These gases are primarily simple asphyxiants, which may cause dizziness or drowsiness in higher concentrations. Their major hazards are extreme flammability and freezing effects, since they are pumped and stored at temperatures and pressures that keep them liquid. Hydrogen is not technically a hydrocarbon, since it is pure H2 gas without carbon atoms. Hydrogen is the lightest gas. It will quickly dissipate into the atmosphere, but it may accumulate at ceiling levels. The first hazard of H2 is extreme flammability. The upper flammable limit is 74% H2 in air, and the lower is 4%. Hydrogen also burns with a colorless flame, so an H2 fire is not usually detectable by sight. Hydrogen is pumped as a liquid. Since H2 isn't liquid until below minus 423 degrees Fahrenheit, the freezing effects are a major hazard. Wear chemical goggles, a face shield, and loose protective clothing and gloves if you have to work in the vicinity of liquid H2. Since H2 isn't toxic, any first aid for contact will be in response to the freezing effects of the liquid. Butene, also called ethylethylene, is another highly flammable compressed gas. Butene's flash point is minus 110 degrees Fahrenheit, and its flammable range is 1.6% to 10%. Butene may explode in the presence of oxygen. Butene gas will also collect in low areas. Although colorless and odorless, high concentrations of the gas may cause an anesthetic effect. Basically, your body becomes numb. Wear protective goggles and gloves to keep from contact with the very cold liquefied compressed gas. If ventilation is poor, wear SCBA. Propylene is a highly useful feedstock for many applications. It's a colorless gas with anesthetic health effects and freezing effects when a liquid. Propylene is highly flammable. It will flash at minus 162 degrees Fahrenheit, has explosive limits of 2% to 11%, and will accumulate in low spots since the gas is heavier than air. Propylene may react violently with either heat, without a spark, or oxidizers. When working with liquid propylene, wear goggles and clothing to protect yourself from contact with the very cold liquid. If ventilation is inadequate, wear self-contained breathing apparatus. Ethylene is another very valuable feedstock. It's a colorless gas with a slight odor like ether, and it may be an anesthetic when breathed. Ethylene is noted for being a major fire and explosion hazard, second only to hydrogen in our system. Ethylene will flash at 136 degrees Fahrenheit and has a wide explosive range, 3% to 32%. Ethylene will also react violently with oxygen, chlorine, and localized heat. Ethylene has been known to decompose within a pipeline under pressure shock, and above ground, ethylene lines should be insulated for protection from grass fires or other localized heat sources. Ethylene gas, however, is slightly lighter than air, so the vapors tend not to collect in low spots. Personal protection requirements when you make contact ethylene include SCBA in high vapor concentrations. Ethylene gas is not harmful to skin. Safety glasses should be worn to avoid a jet of gas, but chemical goggles are not required. Unlike other gases which are liquefied, ethylene is transported under pressures which allow it to remain a gas, so the freezing effects of liquefied gases are not a hazard. Debutanized natural gasoline, or DNG, and pyrolysis gasoline have similar hazardous characteristics to Amoco gasolines. Very low flash points, moderate flammable vapor ranges, and minor eye or skin irritation on exposure. These liquids are also harmful or fatal if swallowed, and their vapors will accumulate in low spots. Breathing vapors from DNG or pyrolysis gasoline may cause dizziness, headache, or nausea. Wear goggles, gloves, and protective clothing if you may come in contact with these liquids, and use an organic vapor respirator if ventilation is inadequate. Benzene is a water-clear liquid with an aromatic odor and is the most hazardous hydrocarbon pumped in APL in terms of toxicity. Benzene will cause a slick on water and has a flash point of 12 degrees Fahrenheit. Its flammable vapor limits are 1.4% to 8% in air. Benzene vapors are heavier than air, so they may accumulate in low spots. Exposure to benzene liquid or vapors is very dangerous. Benzene will irritate your eyes and redden your skin and can produce dermatitis on prolonged contact. Low concentrations of benzene vapors will cause dizziness, headache, breathlessness, mental confusion, and drowsiness. High concentrations may produce paralysis and death. 1.6% benzene vapors in air is the median lethal concentration for a 4-hour exposure for laboratory rats. That means that half the rats exposed died at this concentration over this length of time. Repeated low-level exposures to benzene can cause anemia by damaging the blood-forming system in your body. Repeated exposure to benzene may also cause cancer. The threshold limit value for benzene vapors is 10 parts per million. If contact with benzene is a possibility, full protective clothing should be worn. This includes chemical goggles, rubber gloves, and clothing which will not permit benzene to contact your skin. Above the limit of 10 ppm, wear self-contained breathing apparatus. Emergency response and first aid for persons who have been exposed to benzene liquid or vapors include immediate washing of skin, clothing, and eyes with water, and providing fresh air or oxygen. Prompt medical attention is important, especially for unconscious victims. In summary, the biggest hazard to persons in Amoco pipeline is the ever-present danger of fire and explosion. Secondary hazards are the physical effects of exposure to the liquids and gases we pump, eye and skin irritation, the possibility of asphyxia or intoxication in vapor-rich atmospheres, freezing effects from liquefied compressed gases, and certain toxic effects, notably from benzene and xylene. Remember that all hydrocarbons should be handled with the caution they deserve, and also that Amoco Pipeline and Standard Oil Company want you to be aware of the possible hazards, so you can continue to work safely and efficiently, whatever your job.